Hey there, welcome back. So in this video, I'll try to cover the post-order traversal of the binary tree. First, I'll explain with an example, and then we'll go ahead with the code and execution part. Okay. So let me take the same example which I referred for the in-order and pre-order traversal only. So let me quickly write that example. So this is the example. Okay. So yeah. Fine. So let me, okay, it's not this, I missed. Okay, yeah, the same example as previous ones. So here the traversal, the part is like, first we will touch the left child and then go for the right child and then to the parent node. Okay, so that is the thing here which I have already written here. So this is the core the logic of this traversal. So let's assume that initially we are at this node. Okay, so now what would be this post order traversal is? For now I'll just write the output is for 8 2 5 2. Okay, 6 9 10 7 3 1. Okay, this is the post order traversal of this tree. I will now explain how this was achieved. Okay, so assuming now we are at this node initially. So as I said, the traversal is left child, right child, and then parent. Okay, so is there a left child for this node? Yes, so we will go for node 2. Again we check, is there a left child for this? Yes, there is. So now this root node, so now we'll check for this, is there a left child? So there is no left child. Okay, again check for the right child, is there a right child? No. So then this parent, so that is how the first node in the post order traversal would be 4. Okay, now go back to its parent. Okay, now is there a right child for this? Yes. Again now this will become as root node. Again we should do the same, left, right, and parent. Okay, is there a left child for this? Yes. Now we'll go and explore the left child for this. Is there a left child for this? No. Okay, again is there a right child for this node? No. So then this would be the parent, and then we'll print this. Now we'll go back to this root node 5. Again check for right child, is there a right child? No. So now this would be the parent, so we print this 5. Again go to its root node, that is the left and right child of root node 2 is explored. So now we have to print the root node 2, which is a parent. Now go back to its its root node 1. So is there a right child for it? Yes. Okay, and again this will become a root child. First explore the left child and the right child and then itself. Okay, so go to its left child, this 6 would become the root node. Now is there a left child for this? No. Okay, is there a right child for this? No. So this becomes the root, so we print that. Again go back to its parent, is there a right child for root node 3? Yes, so go to its right child. Is there a left child for this root node 7? Yes, go to root 9. Is there a left child for root node 9? No. Same, check for the right node? No. So this becomes the parent, so we print that. Go back to its parent, is there a right child for root node 7? Yes, go to its right child. Again check for a left child of root node 10. No left child. And also check for right child. No right child. So this becomes parent, so print that parent. Go back to its parent, the left and right child of a 7 is explored, so print that too. Okay, and then go back to its parent, the left and right child of root node 3 is also explored, print the 3 and go back to its parent 1. So here for root node 1, the left part is completely explored and also the right part is also completely explored, so only thing left is itself, so we print it. So this is how we would be able to get the post order traversal of the given tree. Now coming down to the code part, so just I'll write the pseudocode, just same like let's say this as post order traversal, and let's say here we'll have the root node. Okay, here base condition is obviously is needed. If root is null, we will just return. Here the first thing is we will traverse the recursively the left part of our tree as I explained above, that is root to left, okay, and then go recursively for the right child of the node we are at. So this is right child, and finally we print the root value, okay. So this is the rough pseudocode of post-order traversal. Okay, so now let me try to explain the function call, how the function calls will happen. So assuming, so this, let me take this tag. So first we are at this root node 1, okay. So we are at root node 1. Now what we do is root equals to null? No. So that is what we check. So again, root pre-order traversal, sorry, post-order traversal root to left. Root to left is there. What is root to left? 2. Okay. So we'll push 2 here. Okay. Fine. Again, so again the function call is 2 equals to null? No. So we'll push the left child of the root node 2, that is 4. Okay. Again, if 4 is equals to null? No. So post order traversal root to left. So here there is no root to left. So for now we'll push it as a null. Okay. So again go to its root. Now check if root equals to null. Yes. So what we do here, we return here. Okay. We return to this. So this is how the stack becomes after this. Here 1, here 2, and here will be 4. Okay. So now the right child of root node 4. Okay, and that is post order traversal root to right. Go here. Okay, and root to right here was null. Check again, is root equals to null? Yes, it is true. What we do is again return here to this 4. Okay, so again after this the call stack would be like this: 1, 2, 4. Okay, fine. So the right part was also completed here. I mean, this part was also completed. So next step is will be printing 4. So here this is where we print 4. Okay, and once we print 4, this will be taken off the stack. So this is how the call stack would become, that is 1, 2. Okay, so that was done. Now the 2's left child was explored. So now it will go to this this part. Okay, here, this part. So 2 to right, what is the 2 to right? 5. So 5 will be pushed. Again check if 5 equals to null? No. So again the left child of the node 5 will be pushed into our stack. So left child here is 8. Okay, and check again for is 8 equals to null? No. So again push the left child of root node 8. Here it is null, so we'll push null. Again it will return back to 8. So again push the right child of it, null, it will return back to 8, and then finally 8 will be printed here. Okay, 8 will be printed and it will be taken off the stack. So the next stack will look like this: 1, 2, 5. Okay, this is how the stack will look. Now 5 again, left part was done. Okay, so we go for the right part again there is null, so we'll push null. Root becomes equals to null, we return back, and it will come back to the 5, and that is where we print the 5. Okay, so this is how 5 will be printed and it will be taken off the call stack. So this is how it will look. Okay, if I draw 1, 2, 5 is also printed. Okay, next 2 was 2 root left part is done, right part is done, so it will come to this step. So this also will be printed, that is we will print 2. Okay, so after this the stack would look like this. So yeah, so for 1 the left part was explored, that means for 1 this step is completed. Now the next step is root to right. So all right child of 1 will be pushed now. So right child here is 3, so here we'll push 3. Check again, is 3 equals to null? No. Again we'll push the left child of the 3 into the stack. Left child here is the 6. Okay, left child is 6. Again we will try to check is 6 equals to null? No. Push the left child of 6, here it is null, we'll push null again, that will become equals to null, we'll return back to 6. And also now push the right child of 6, which is null again, and null will be pushed, and we'll compare with the root equal to null, again that becomes true, we return back to 6, and that is where we print the 6 here. Okay, we print 6 here. And okay, after this the stack looks like this. Okay, 1 3. Okay, so 3 left children was done. So now we check for the this pre-order post order traversal root to right. So this again, yes, there is a right child, so 7 would be pushed. Again we check if 7 equals to null? No. So again we'll push the left child of 7. So left child here is 9. Okay, we'll push 9 here. Okay, again so we'll check, is this equals to null? No, it's not equals to null. So post order traversal left child here it's null, we'll push the null, check with the root equals to null, becomes true, we return back to its 9. Again push the right child, that is null, we return to 9. Okay, and this is where we print 9, and we'll take it off the call stack. Okay, so this is how it will look after this. That is 1 3 7. Okay, so here the left child of 7 was done. So now we check for, is there a right child of 7? Yes, there is. So we push the right child of it. Again for this becomes as a root. Again we'll try to explore the left and right child of 10, which in this case both are null. So this will return back to its 10, and finally we'll print 10 here. Okay, that is print 10. Okay, after this the stack will look like this: 1 3 7. Okay, now 7, the left child was explored, and right child was also explored. Now this is parent, so here again we'll print this 7, and this will also be taken off the call stack. So it will be finally like this. And for 3 also, if you see, the left part was done and right part was done, so we will print here 3. Okay, and finally we will be left with 1, and we will print this one as well. Okay, print 1 as so this is how the function call stack would look like if we write code in this way. Okay, so that was the thing. And even if you see the output, see, first we printed 4 8 5 2 6. Okay, and this is 9. Okay, fine. This is 9. Okay, which is correct, 9, and then 10. Then next should be 7 3 1. Okay, 7 we printed, 3 we printed, 1 we printed. Okay, so this is the how the function call stack will happen for this post order traversal. Okay, so now the explanation part is done. So we'll go and try to write the code part for it, and execute the same example and see what the output would be. Okay, yeah, so I have created a postorder.cpp file. So we will import the headers. Okay, here IO stream, and then I would use a vector here, so I need this. Fine. So after this using namespace std also I will import, and then I will create a data type for our node, that is struct node. Okay, and then for this we will define one value and then left and right pointers. Okay, so that is left and right child. Okay, fine. So then we would write the function for Postorder Traversal, that is Postorder, let me make this Postorder Traversal, and then here we would pass the root node reference. Okay, and also one array to push all the Postorder Traversal no values. Okay, so here I will name this as like post order. So here first check could be if root equals to none, we will return. Okay, or else what we do, we will first explore the left child, then right child, and then push the root value to our post order array. Okay, so if I write, so this post order traversal root to left, and then pass this post order array, and then post order traversal for root to right, and then push the pre-order, sorry, not pre-order, post order. Okay, post order array, and then here push that root. So here I think I forgot this. Okay, here again push that root value to our post order array. Okay, so post order dot pushback root to val. Okay, so this is the function for post order traversal. So now we will write one function to push to create new node. Okay, so new node, and here the value would be input parameter, and then we would create new node. Okay, and of type this struct node star, and allocate the memory that this node needs. Okay, so size of that struct node itself. Yeah, so this is it, and then we will assign value for this, that is temp to var is value, and then temp to left and temp to right I will assign null. Okay, fine, and then return the temp. Okay, so this is the function to create a new node, and finally we'll write our main part, and then try to create the example which we have seen just now, and then see the output of it, is it matching to our explanation or not. Okay, so here a new node is 1. Okay, root to left again, new node is 2, root to left is 4, and again root to left to right is 5. Okay, and then root to left to right to left is 8. Okay, and then root to right now, root to right is 3. Okay, then root to right to left, this would be 6, and root to right it would be 7, then root to right to right, this would be 10, and finally one more name for this root to right to left, it is 9. Okay, so this is the example, the structure of our example which we have seen. And now I will define one vector for holding the post order traversal of our tree, and then call our function, that is post order traversal, passing root and then this post order array. Okay, and finally we will check what is the post order traversal of this list, print out the contents of a post order array. Okay, so this is how, and then traverse that the post order dot size, then okay, and then print that value of that particular indexes. Okay, post order of high, and give space between every element, and then return 0. Okay, so this is the code part, and let's see the output of this. Okay, so I'm running this code. Okay, yeah, so if you see, the output is I mean, I ran 2 times. Okay, fine, no problem. So the output is exactly the thing which we got while we were explaining, that is 4 8 5 2 6 9 10 7 3 1. Okay, so yeah, so this is it for this post order traversal video. In the next video I'll discuss about left view and right view of binary tree. Okay, so thank you so much.